Hello, beautiful calculus students. Welcome to section 3.9, day 1 lesson, finding the derivative of exponential and logarithmic functions. We actually have 4 formulas we're going to go over today, but before we do that, I always find that it's good to review exponential properties and logarithmic properties on the days that we do these derivatives. Please keep in mind all these exponential properties that you actually learned in Algebra 1, you reviewed in Algebra 2, you saw again in pre-calc, and now you're seeing them again. So hopefully at some point they've been ingrained in your brain. Anything to a 0 power is 1. When you multiply two variables with the same base, or two numbers with the same base, you add their exponents. When you divide two terms with the same base, you subtract their exponents. And when you raise a power to a power, you multiply the exponents. Okay, with logarithmic functions, remember that log base a of a 1 is always equal to 0, which means the same as the exponential property of a to the 0 equals 1. All right, anytime you have the addition property, you have the power property where you take the power, put it in front of the log. You have the division of logs, which means that you subtract. And also you have the change of base property. We also have this function on our calculator now. I believe it's alpha windows. So you can check that out. You can actually put the log into your calculator now. So the change of base property is not used quite as much, but we'll see. All right, the first derivative we're going to learn, I said there were 4 of them, is e to the something. You're going to love this one, because derivative of e to the x is just e to the x. All right, times the derivative of the u. Again, this is your u, but in this case, u is x and u prime is 1. So the derivative of e is e. I love it. Okay, next. Let's try another one. Might be a little more complicated. In this time, we have a u of 2x minus 1. And therefore, our derivative equals 2. So the derivative of e to the 2x minus 1 is just itself, e to the 2x minus 1, times the derivative of the top, which is 2. So that is our answer for part B. Part C, actually 4 examples here. We have e to the negative 3x. Well, let's just take it up one more notch. U is equal to negative 3 times x to the negative 1. We all know how to take the derivative of that. Negative 1 times negative 3 is a positive 3, x to the negative 2. So our derivative, remember you always just write down the e function like you see it, and then you multiply times the derivative of whatever the u was. So this is also the same as x squared in the bottom and 3 in the top. So our derivative for part C looks like this. And last but not least, we got to throw a trig function in there for kicks and giggles, e to the tangent x. So this time our u is tangent, and you remember that our derivative of tangent is secant squared. Okay, so the derivative of e to the tangent is secant squared of x times e to the tangent of x. All right, that's that derivative. All right, next rule. All right, this is the derivative of an exponential function. When we say a to the u, we mean something like 3 to the x. Not to be confused with x to the 3rd. All right, a is a constant, and u holds the variable. So, but this equation for the derivative is a little teeny bit more complicated. ln of a a to the u times the derivative of the u part. So sometimes it's helpful to identify right off the bat what's a, what's u, what's the derivative of u, and then plug it into the equation. All right? So 2 to the x. In this case, a is equal to 2, u is equal to x, and then the derivative of u, we like this one, the derivative of u is 1, or du dx. All right, now we just are going to plug those into our formula, which you have to memorize. No ands, ifs, or buts about it. ln of a, so our formula is ln of 2, which is just a number. And then we take 2 to the x times the derivative of u, which is 1, which we don't really have to write. So that's our answer. ln of 2, 2 to the x. All right, let's look at another example. The derivative of 12 to the negative 3x. All right, so a is 12. U, I don't want to do u prime yet. Let's do u is negative 3 x's, and u prime is just going to equal negative 3. So our derivative is ln of the a, which is 12. Remember, ln of a number is just a number. And we have 12 to the negative 3x. And then we have times negative 3. I'm going to write the negative 3 in front of all this, and that will give us our solution derivative equation right there. ln a to the u, du dx. Example 3. Oh, good, that's it. Oh, yes. All right, 6 to the tangent. I think you get the idea. A is 6, u is tangent, and u prime equals secant squared of x. All right, so let's write this one. Remember, you're always repeating what's in here, a to the u. But you're starting out by writing ln of 6. I like to put it in parentheses because it's just a number. Then you have 6 to the tangent x. And I'm going to write secant squared right in front of these. Secant squared of x. These are all multiplied together, so if you want to include parentheses like I did, that'll make sure no one messes up your angles and ln's and all that kind of stuff. All right, that is the second derivative equation. Now we have the third derivative formula. And big log, log of a to the u. Next preview, we're going to do ln of u. So don't confuse those. Remember, ln is just ln of e. Remember, log of e equals ln. So don't forget that little fact either. I don't know if I had that on my other little fact sheet. But anyway, log of a to the u. Again, we're going to need to identify a, identify u, identify the derivative of u, and plug it into the equation. All right, that's the way to keep it simple. Remember the KIS rule. Keep it simple, silly. All right, so u equal, well, let's start with a. A equals 2. We have a base of 2. A is your base. U equals x squared in this case. The derivative of u is 2 times x. All right, once you have that determined, you're going to use your trusty formula. 1 over ln of 2, ln of a, times u, which is x squared. And then you multiply times the derivative of u, which is 2x. So times 2x, I'm going to write it on the top, 2x. And we can actually simplify this just a teeny bit, can't we? By canceling out 1x here and 1x here. And we get 2 ln of 2 times x. And that is our final answer. Okay, our next example is a little bit trickier, but not really that difficult. Okay, so we have log base 3 of 1 plus x ln of 3. All right, so let's start off by identifying a. A is 3. u is 1 plus x ln of 3. Okay, well, we can take the derivative of that. U prime equals, remember, derivative of 1 is 0. The derivative of x times ln of 3. Ln of 3 equals a number, all right? So this is like having a 4x, all right? The derivative is just the number. So number times x, the derivative is ln of 3, okay? So we don't need the 0 written there anymore. Derivative is ln of 3. So let's just plug into our equation and see what we get. 1 over ln of 3, which is ln of a, times u. U is 1 plus x ln of 3, times the derivative of u, which is ln of 3. ln of 3, I changed that 1 to an ln. All right, now if we look at this, I think we can cancel out the ln of 3's. And so our final answer is going to be 1 over 1 plus x ln of 3. That's our final answer for the derivative of part B. Now, part C is one more example. 1 over log base 5 of x. So let's go ahead and, well, it looks like we might have to use chain rule here. All right, let's rewrite this to the derivative of log base 5 of x to the negative 1. All right, now I'm going to have to take the derivative of the outside and then multiply times the derivative of the inside, which will be, the derivative of the inside will be using our equation. But the derivative of the outside is negative 1 log base 5 of x to the negative 2. And then we're going to have to multiply times the derivative of the log. Okay, so you can write that derivative of log base 5 of x. So let's figure out what this part is. And then we'll go back and plug that into our equation. So once again, a is 5, u is x. I love it. U prime is 1. So using our fancy-dancy equation, we take 1 over ln of 5 times u, which is x, and then we multiply times 1. So this is the derivative of this over here, and we're just going to plug that into our equation, plug that into for the derivative, and then rewrite it. All right, so the derivative of, I'll just move this down here. The derivative of this equals, we have a negative, and don't forget, this is to the negative 2, so I'm going to write this underneath, log base 5 of x squared, because that's underneath, and then we have ln of 5 times an x. And on the top, we just have a negative 1. So that will be our fancy-dancy derivative. All right, last rule for this section is ln of u. This is probably the one we use the very most. So if you forget all the rest, this is the one you're going to use the most. So don't forget all the rest. You won't, I know. All right, we have 2 examples using the natural log. And again, we're going to, this time we're only going to have to identify the u because the base we already know is e. So this one we're going to identify the u, which is 2x plus 2. And we have to identify the derivative of u, which is just 2 in this case. So we're going to plug this into the equation. It's always 1 over the argument, this is the argument, 1 over the argument, times the derivative of the argument, which is just 2. So we're going to multiply the top by 2. Now, this little guy can be, what do you call it? Simplified. If you divide everything by 2, you get a 1, and a 1. So this is the same as 1 over x plus 1, which would be the best answer. Okay, the second example, a little bit more complicated because we're going to maybe have to use some chain rule stuff. But that, I mean some actually quotient rule. No. Product rule is what I'm trying to say. All right, so we have product rule, this times this, and then we have a minus x. So let's start by taking the derivative of x times ln of x. All right, so we need a u, because we have one function which is x. And you should notice that this is a function times a function. We have to use the product rule. Okay, whenever you see a function times a function, the second function is ln of x. All right, the derivative of v is 1 over x times 1. And the derivative of u is 1. So we're going to take the product rule of this. V times u prime, which is just ln of x, plus x times 1 over x. Ooh, that's just a 1. Minus, and don't forget we have this now, minus the x. The derivative of x is 1. All right, so this looks like we have plus 1 and minus 1. We can cancel out. So our derivative is just ln of x. All right, so those are our examples. That is section 3.9, day 1. Thank you for tuning in.